So in Chapter 1.8, I would like you to review pages 179 through 183. We're going to be discussing absolute values and inequalities. So our objectives in this chapter is going to show you an example of solving a one absolute value equation. Then we're going to go to solving a two absolute value equation, and then I'm going to show you some inequalities, an example of solving a less than absolute value, and then an example of solving a greater than absolute value problem. Our first objective is to solve a one absolute value equation. This is number 18 on page 184. Here we have 4 times the absolute value 2t plus 7 plus 2 is equal to 22. The first step is we're going to isolate the absolute value sign. So we subtract 2 from both sides, and this gives us 4 times the absolute value of 2t plus 7 is equal to 20. Then we're going to divide both sides of the equation by 4, and that gives us the absolute value of 2t plus 7 is equal to 5. Now, we can break this absolute value up into two pieces. One piece is the plus piece. In other words, the inside of the absolute value can be positive. So that means 2t plus 7 can equal a positive 5, which when we solve for that, we find that when we subtract 7 from both sides, we get 2t is equal to a negative 2, and when we divide by 2, we get t is equal to a minus 1. Now we can also have the inside part, 2t plus 7, equal to a negative number. And in fact, what we're going to do is multiply the right-hand side by a negative, and we get a negative 5. So 2t plus 7 is equal to a negative 5. And now we subtract 7 from both sides, so we get negative 2t is equal to a negative 12. And t is equal to a negative 6. Well, we have two solutions, negative 1 and negative 6, but we have to check to see if they work. So we did the work, so we did it in red. We tried negative 1, and in fact, negative 1 works. So when we plug it in, we get 22 is equal to 22. That's a good sign. And when we plug in negative 6, we also get 22 is equal to 22. It's important to put back the original numbers into the original equations to see if we have any contradictions. The second objective is going to solve absolute value equations for two absolute values. This is problem number 26 on page 184. We start out with the absolute value of 2a minus 3 is equal to the absolute value of a plus 2. So again, we break on the left-hand side, we look at the left-hand side absolute value, and we break it up into two pieces. One is the plus portion, and the other is the minus portion. So in this case, we have 2a minus 3 is equal to a plus 2. That's the plus portion. Now we add 3 to both sides, and we subtract a from both sides, and we end up with a is equal to 5. We're going to do the same thing with a negative. But this time around, it's 2a minus 3 is equal to a negative parentheses a plus 2. everything on the left-hand side is multiplied by -1. We distribute the -1 and we get 2a minus 3 is equal to a -a minus 2. Well, now we're going to add 3 to both sides, and we're going to add a to both sides, and we get 3a is equal to 1. And we divide by 3, and we get a is equal to 1/3. Okay, so now what do? Well, we check our answer. So we put 5 in, so absolute value of 2 times 5 minus 3 is equal to an absolute value of 5 plus 2. The absolute value of 10 minus 3 is 7, and so the absolute value of 7 is equal to 7. We'll do the same thing for 1/3. We get 2 times 1/3 minus 3, absolute value, and the absolute value of 1/3 plus 2. And when we do the arithmetic or the math, we see that we get the absolute value of -7/3 is equal to the absolute value of 7/3. But the absolute value of a -7/3 is a +7/3, so it checks out. So both solutions work in this case. In this case, the solution is 5 and 1/3. So now we're going to solve an inequality, and we're looking at problem number 41 on page 185. If you look at the book, you'll see this equation, -11 is less than or equal to 5 minus the absolute value of 2p plus 4. Now, the first step is always to isolate your absolute value. And so what we're going to do is we're going to add a -5 to both sides of the equation. We're going to subtract 5 from both sides of the equation. That gives us a -16 is less than or equal to a negative absolute value of 2p plus 4. Now, we're going to divide both sides of the equation by a negative. Well, when we do that, the sign of the inequality changes, and we get 16 is greater than the absolute value of 2p plus 4. Well, 2p plus 4 can be a positive or a negative, and in fact, it's going to be between 2 points. If we look at the negative side of -16, it's going to be between -16 and a +16. So now our equation is -16 is less than or equal to 2p plus 4 less than or equal to 16. So whenever we have this situation where we have a number greater than an absolute value, when we take the absolute value sign away, we have what's ever inside the absolute value between the numbers, the negative part of the number and the positive part of the number. So now you can see, what do I do next? Well, I subtract 4 from every part of the inequality. So I subtract 4 from the inside, and I subtract 4 from the 16, and I subtract 4 from the -16. So that gives me a -20 less than or equal to 2p less than or equal to 12. And now I can divide through both the inequalities by 2, and when we do that, we get a -10 less than or equal to p less than or equal to 6. So our solution is an interval between -10 and 6. So it's every number between -10 and 6. And so here's our graph, right? And this is how we can graph this solution. This is the graphic solution to our problem. Now we have a greater than. So this is problem number 39 on page 185. And as you can see, we have 2 times the absolute value of x plus 3 minus 4 is greater than 6. The first step, of course, is to add 4 to both sides of the equation. We get 2 times the absolute value of x plus 3 is greater than or equal to 10. Then guess what? We divide by 2 and we get a negative, or we get an absolute value of x plus 3 is greater than 5. Now, in this particular case, it's also possible that we have a negative 5, and when we multiply by a negative on either side of the equation, the negative doesn't really apply to the absolute value, but we have a negative 5 is now greater than or equal to the absolute value of x plus 3. So we have two equations that we're going to solve for. The first one, we will solve x plus 3 is greater than 5, right, when we take the absolute value sign away. And this now becomes x is greater than 2. Why? Because I subtract 3 from both sides. So my solution for this particular x greater than 2 is in interval notation, bracket 2 comma infinity. Now I will show you the bottom part where we have negative 5 is greater than x minus 3 absolute value. When I take the absolute value sign away, I get a negative 5 is greater than x plus 3, or x is less than, right? And you say, well, how can that be less than? Well, it is. X is less than negative 8. So here we have interval notation of a negative infinity to a negative 8 bracket. It can be 8, but it can't be a negative infinity, obviously. It's not a number, right? So here is my graphic solution, right, of the problem. And as you can see, I have a bracket at 8, and it's now going in the negative infinity direction, and I have a bracket at 2, and it's going in the positive infinity direction. So as you can see with the greater than absolute value, when we break down the absolute value into two pieces, we have an absolute value greater than the number, or we have a negative number greater than the absolute value. And that's important because when we put the numbers into the solution, they have to work in the original equation. Well, that concludes our chapter 1.8 examples. Please go through the book and work a few more and look at the examples in the book. And we'll be discussing this also in class.